As we move forward, we want to practice some other stoichiometry calculations. So we've already looked at how to convert grams of a substance into grams of another, but as long as we have the moles of a substance, we can calculate any measurement related to moles like we did in the first unit. So we should be able to calculate particles. Okay, once we've done the mole-to-mole ratio, we could get the particles of it by using Avogadro's number. We could do grams like we did in the previous video with the molar mass, and that's blank because the molar mass is different depending on what your formula is. Or we could go to volume, and we know that 22.4 liters is equal to a mole. And that's only for gases if they're at standard temperature and pressure. Some general steps that you're going to want to follow. First of all, your given amount needs to be in moles. So let's say that they give you liters. Well, you're going to have to convert that to moles first, and then we can go from there. If it's already given to you in moles, then you're fine. Okay, step A, good to go. Once you have your original amount in moles, we want to use our mole-to-mole ratio, and we want to convert that to whatever our new substance is. So maybe we're going from water to just hydrogen, or whatever elements and formulas are in your balanced chemical equation. Make sure that you do have a balanced equation. But once you have your moles of your new substance, then we can convert to any of these above measurements. So when it says desired measurement, you're going to want to look at the problem. Is it asking you for grams? Is it asking you for volume? Is it asking you for particles? That's going to determine which of these you are using. So it's if asking you to go to grams, you need to use the molar mass. If it's asking you to find the volume, then you're going to need to use the 1 mole is 22.4 liters. If it's asking you for particles, then you're going to need 1 mole is equal to Avogadro's number. So it depends on what it's asking you for. So let's say that we wanted to take our grams of hydrogen. We've used the equation on making ammonia several times, so we know the equation is N2 plus 3H2 equals or yields 2 ammonia. So let's say that you're given grams of hydrogen. Well, the rules say that we want to convert it to moles first. So in order to go from grams of hydrogen to moles of hydrogen, there's where we're going to need the molar mass. So we're going to need that 1 mole is equal to however many grams. Now the next step says we want to use our mole-to-mole ratio. So we take our moles of hydrogen, we want to convert it to moles of ammonia, and we do that with our balanced equation. So we need to know the mole-to-mole ratio. We look at the coefficient in front of each of those, and that's what we're using for our number of moles. And then it wants to know molecules. So once we have moles of NH3, we can convert to molecules by using Avogadro's number. And because N and H are both nonmetals, this would be molecules. 6.02 times 10 to the 23rd molecules is equal to a mole. So let's do some different practice problems. And this is really utilizing what we've already practiced, but it was a few units ago, so we just need to refresh our memories. How many molecules of oxygen are produced when 29.2 grams of water is decomposed? So we have our equation and it's balanced. So you always want to make sure you're starting with a balanced chemical equation. And then from there, we want to follow our steps. So we were given 29.2 grams of water, and the first step is to convert to moles. And we're still staying with the same substance. So we have grams of water we want to get rid of, and we're just converting it to moles of water. And we do that with a molar mass. So we're always going to have 1 mole, and the molar mass of water, H2O, is 18.0. We've used that one frequently. I have that one memorized. Maybe you do too. And now the next rule says once you have your substance in moles, we want to do a mole-to-mole ratio so that we can convert now to our new substance. So we want moles of water to cancel. We'll put it on the bottom. And the substance that we're looking for molecules of oxygen. So we want to convert right now to moles of oxygen. And we're going to use our balanced chemical equation. We have 2 moles of water we have only 1 mole of oxygen. So we're putting those coefficients in from our balanced equation. And the third step was to convert to whatever our desired unit was. So our desired unit isn't moles. We want moles of oxygen to cancel, and instead we want molecules of oxygen. And so 1 mole is equal to 6.02 times 10 to the 23rd molecules. And from there we've canceled out all of our units except for the molecules of oxygen. And if we take 29.2, we want to divide it by 18, we want to divide it by 2, and then we want to multiply by 6.02 times 10 to the 23rd, and we're only allowed 3 significant digits, and so after some rounding we're going to have 4.88 times 10 to the 23rd, and that is molecules of oxygen. So make sure that you're giving me not only the unit but also the substance that we're using. So let's go ahead and try another one here. We want to know how many liters of nitrogen dioxide gas are produced when 34 liters of oxygen reacts with an excess of nitrogen monoxide gas. Now in this case, notice there's no balanced chemical equation given to us, and this isn't one that we've practiced with in previous slides. So we're going to have to start off with making or writing a balanced equation. So this is the past unit we just did. We need to be able to balance equations and write in our reactants and our products. So if you reread this carefully, it wants to know liters, but it says that nitrogen dioxide gas are produced. So we know that nitrogen dioxide is a product, and that's NO2 because of dioxide is 2 oxygens, and we know that that's a gas. And it says that oxygen reacts with an excess of nitrogen monoxide. So oxygen is a reactant and it's reacting with nitrogen monoxide. Oxygen is special, so whenever we write it we have to put O2, and nitrogen monoxide is NO, and all of these are gases. Oxygen is what we breathe, it's a gas. And that's just our chemical equation, and now we need to balance it. And in order to balance this one, we're going to want to put a 2 in front of our NO, and that's so that we end up with 4 oxygens. We have a balanced or an even amount of oxygens, which we then can come over here and we have 4 oxygens and our 2 nitrogens. So there's our balanced equation. We have to start there first. And now we can convert our 34 liters of oxygen into liters of nitrogen dioxide. And we're going to do that by following our rules. Whatever we're given, in this case liters, we want to first convert things to moles. So moles is going to be our key component in all of these problems. So liters to moles, our conversion is that 1 mole is equal to 22.4 liters. From there, and that cancels out our liters, by the way. Now from there, our rule was that we need to do our mole to mole ratio. So we want to take our moles of oxygen, and the substance that we want liters for is liters of nitrogen dioxide. So we're going to have to start by getting moles of nitrogen dioxide. That'll allow our our moles of oxygen to cancel. And if we look at our balanced equation, our moles of oxygen is a 1, and our moles of nitrogen dioxide is a 2. So we're plugging those numbers in from our balanced equation. And then the last step was to convert to our desired unit. In this case, our desired unit is liters. So we want to convert moles of our nitrogen dioxide into liters of nitrogen dioxide. And we're going to be using our 22.4 liters per mole because we're at a gas and we're at standard temperature and pressure. So our moles can cancel, and now it's just a matter of plugging things into our calculator. So take 34, divide it by 22.4, multiply it by 2, multiply it by 22.4, and you have 68. You're only allowed 2 significant digits. Your original number only had 2. That's the lowest amount. So 68 liters of nitrogen dioxide gas. Now this last one I'm going to have you work on. This is going to be your problem. You're going to follow the same steps. We're starting with liters of oxygen, and so your first step, if I'm just walking you kind of through this, you're going to be setting it all up. You're going to start with your 37.4 liters of oxygen, and you're going to want to convert that to moles of oxygen. You're then going to want to use your mole to mole ratio and go from moles of oxygen to moles of sulfur trioxide. Make sure you're doing the trioxide. And then from there, once you have moles of the sulfur trioxide, we can convert moles to grams, but you are going to need the molar mass of sulfur trioxide. So that's something that you're going to need to calculate off your periodic table, because you're going to need that. So I will check that one when I see you next, and if you have any questions, like always, please let me know.